deputy head. So Mark graduated from the Technical University Berg Academy Freiburg in Germany, where he studied classical mechanical engineering with a focus on renewable energies. He then moved into the world of bits and bytes, earning a PhD in computer science for developing a vision-based 3D reconstruction technique for use in underground service and exploration robotics. And in 2022, he joined the interdisciplinary research team at the German Center for Rail Traffic Research, working on automation, robotics, and infrastructure monitoring. He's deputy head of the research German Center for this center. And his talk will be about railway infrastructure monitoring in a nutshell, from concepts and possibilities.
Yeah, thank you for the brief introduction and welcome from my side. I'm just a research scientist and presenting you my topic, railway infrastructure monitoring in a nutshell, concepts and possibilities. And this is just a short overview of our project and research fields dealing with infrastructure monitoring, and it's more like a comic style presentation. So after this great lunch, you can relax a little bit and keep yourself comfortable. So possibly you never heard about the German Center for Rail Traffic Research, and this is because we are a really young institute. We were founded in 2019 by a governmental order. So that's why I will tell you something about our institute. We are located in Bonn and in Dresden, and Dresden is supposed to be the headquarters. Now I come to a little more information. We have 36 employees in Dresden and 33 employees in Bonn, and we have a good balance between men and women. And keep in mind, we are a technical institute. So we have a huge academic backgrounds from different perspectives of research because we deal with all questions that are related to the railway sector. We also have 5 PhD students and at the moment 3 students doing their internship at our institute. So who are we? Generally speaking, we are a think tank of the Federal Ministry of for Digital and Transport. I hate this name. In English, and at the Federal Railway Authority. So we have to deal with both, with the Railway Authority and with the ministry. We are the connection between research, railway sector, and politics, and our goal is boosting the railway sector. So this is one of our goals, and we do political consulting, and we have a neutral position. And we are responsible for the dissemination and migration of research results and innovation. And we have 4 instruments in doing so. So this is research on request, as you probably all do. There's a funding program, you have a project idea, you write a proposal and find some program partners. Then we have contract research, where we offer projects. We have our own ideas, we offer the project, and you can apply for these projects. And we have a budget of 18 million this year. Next year, we will have a budget of 24 million euros. There is a funding program by the ministry for future cargo rail transport. This is also led by us. This is 30 million per year, where companies can apply for to improve their technologies, their innovations, and to improve their technology readiness level. And we also have our in-house research where we can hire PhD students. We have cooperations with different universities, and we have PhD candidates doing their own research in our lab. So we have 5 departments: strategy, mobility and society, safety and critical infrastructure. And please don't mix it up with your critical infrastructure. This is more related to train control systems and also to cybersecurity. Then climate protection, environments, and sustainability. And this is my field of research, digitization and technology. We also have some laboratories. And as you can see here, we have this is our laboratory. It's called Open Digital Test Field. And you hear the name open because this data is open. And this is in cooperation with Deutsche Bahn. And there we have not our own railroad network, but we can use this from the Deutsche Bahn and test new application technologies under real conditions. And we can also offer this to other institutes and industry partners. It's approximately 360 kilometers, and there are some sections in it where we reach up to 300 kilometers per hour train speed. There's also a European train control system laboratory, cybersecurity laboratory, and noise laboratory. The noise laboratory is also incorporating the ODT. We built up their noise barrier walls and want to do some noise monitoring, continuous noise monitoring. Okay, so far from our institute, and the heart of every traffic infrastructure are bridges. And bridges are in railroads, in waterways, and on roads. And this is just a few numbers from Germany: 40,000 bridges for the federal railways, for the federal roads. Sorry, there are many more bridges. 2,300 waterways and 26,000 in the railway sector. So that's a lot. And there is no open secret, or there's no secret, better to say, that there is a high demand on maintenance, repair, and also replacement for these bridges. Monitoring is a nice concept, but usually done when it's too late. So if there's a damage, then usually some owner says, okay, we have to monitor this. So, and this is a problem. We are at the moment at a reactive maintenance concept, and we want to do, or we want to transform this to a predictive one. But what can we do with all the data we are collecting? So there are different questions, and these are only a few of the questions to be answered. So which parameters are of interest, how to collect data, how to reduce data. You're collecting so many data, but what is the necessary information? How to store them, visualize them, and find anomalies. So for example, how can you make sure that there is a damage, or the sensor values come from seasonal changes? So you must find a way to find the difference. Where to find additional data, for example, open data, and how to fuse all these things together. And don't forget, bridges are like humans. You're supposed to know how they work, but each bridge has its own characteristics. So this is an overview of common types of condition monitoring that we are doing, or we let do. So there's a visual inspection, a non-destructive and destructive testing. This is a man-made testing or monitoring the system. Then we have laser scanners, and they are terrestrial laser scanners, and they are getting better and better. We also have continuous monitoring with sensors that are attached to the bridge, and remote sensing by satellite. Nowadays, you can even measure building movements for lifting and lowering in millimeter range over a certain time period, which is really interesting. There's also airborne remote sensing with laser scanners and also cameras, and which is really common nowadays are drones. So and these drones can also carry laser scanners and cameras. So, and what is an emerging technology are mobile scanning devices. Even your smartphone, if you have an iPhone Pro with LiDAR scanning system on board, you can even scan this room in a few minutes, I would say. So this is a really nice technology, especially for bridge inspection. Here you can see some of my colleagues scanning a bridge pier with just using an iPad. And this is really interesting. So you get a first impression of the condition of this pier. And this bridge, by the way, will be transformed into a digital twin within the next years. So next month, there will be a project starting scanning the bridge by using a drone and a terrestrial laser scanner. The upcoming project then turns this point cloud into a building information model. And last but not least, we want to attach sensors to the bridge so we can continuously monitor the bridge and transform it into a real digital twin. So remote sensing allows you to, or allows us to monitor bridges over a larger scale or larger interval. So if you want to have shorter interval times, you need to attach the sensors to the vehicle or to the infrastructure. And there are two types. So usually infrastructure measures infrastructure, so itself, and vehicle measures vehicle. But you can do a mixture of that. So if you have the infrastructure with your sensors, you can also, as we already heard, measure the vehicle. And what we can measure then is the velocity, frequency, also the weight, direction, length, and also the type of the train, which is really interesting for controlling trains. And on the other side, we can say, okay, vehicle measures infrastructure. So think about a train equipped with a lot of good sensors. Then we can measure the infrastructure. And this is called drive-by or indirect monitoring. And as you may know from cars, they have so many sensors in it. So we can do the same with trains. And what we can get from there is we can detect rail defects, track geometry. We also can detect signals, bridge motion, which is really interesting. Also tunnels. And if we go through the tunnel, we can see the shape of the tunnel and also the catenary, especially the catenary mass. And we can also measure the environment, so like surface terrain. And imagine if you can see landslides, or you can get information that there might be a possible landslide within the next time. And also vegetation, especially fallen trees can detect, which is really a problem in railway sector. So, and there are also upcoming technologies. We already heard about fiber optics, and what we want to do is we want attached fiber optics directly to the rail, and also, like I asked you, measure deformation, stress, but also train location, velocity, so all the properties from the train. There is a new technology, or also an emergent technology, that is called ground penetrating radar, which gives us a view underneath the surface. And this view is a unique footprint. And this footprint can be used for train localization, especially in GNS denied regions. And what I find really interesting are event cameras. If you think of color cameras and HDR, high dynamic range, this is hyperdynamic range in this case. And you can get up a frame rate of 1000 hertz and more. So this is really a good sense of simultaneous localization and mapping. So you can track the train, but you can also track the surface of the rails. And last but not least, this is my current and upcoming research. This is called video magnification. And this is a technique to reveal subtle motion from the video material that is not visible to the human eye. So on the left side, here is a guy standing and hammering on the bridge. And in the middle on the right, you will see the extracted modes, the bending and the torsion modes. So we see the bridge starts moving. And this is an interesting technique because you can extract the frequencies of the oscillation and also the mode shapes from the bridge and control the movement of this bridge. So you see, our research has no really end in contrast to this presentation.
Thank you very much. Many exciting developments. For questions? Yes, Laura.
Thank you very much. Very interesting. Can you just explain this last slide? So you can, if I get you correctly, so because it's all a mix in the video, and then you can decouple it and have the torsion and the bending mode. Can you explain?
In order to explain this, I have another presentation. We can later go to this. Keep in mind, there's a slight motion or movement in this. We don't see it, and it's in sub-pixel ranges, but the intensity changes. We cannot see that there is an intensity change because it's 30 FPS. So we don't recognize it. But the algorithm recognizes this illumination change, and this illumination change is dependent on the motion. So, and what you basically do is building up a Laplacian